Nuclear power is both an interesting and very useful technology, and the reactions to it are fascinating too. There is always someone who gets upset when I say that the Fukushima accident really proved how remarkably safe nuclear power is, so I guess I'll have to keep saying it. There's one thing though I haven't talked about before, which is how to transform nuclear waste into less radioactive stuff while making energy from it. Like a lot of nuclear technology which is being developed now, the idea isn't new, but it's only now that serious effort goes into it. And it's about to pay off. Most of the waste from nuclear power plants is slightly contaminated and won't radiate for long. Only about 3% of it is high-level waste, primarily remains of the fuel rods. Left to its own devices, the radiotoxicity of this high-level waste, that's the green line in this figure, takes several 100,000 years to decay to the level of naturally occurring uranium. So what do we do with this stuff? We could bury it, but that seems rather wasteful, because the stuff's basically a battery. It's giving up energy voluntarily. One thing you can do with nuclear waste is to recycle it. We talked about this in an earlier episode. This works for the biggest part of the waste, but not all of it. The problem is that some of the longest living radioactive compounds, such as neptunium and plutonium-242, are not suitable for recycling because they're too difficult to split. This is where transmutation comes in. Transmutation basically means you target the radioactive compounds in the waste and make them decay into something else. Usually the something else is also still radioactive, but it might have a much shorter half-life. The most obvious way of doing this is to shoot with neutrons at the waste, because neutrons are also what induces nuclear fission in a reactor. This idea is known as Accelerator-Driven System, ADS for short. It works by first accelerating protons and then slamming the protons into a target to release neutrons. The neutrons go into the subcritical waste, which induces fission. This releases energy, which heats up the stuff. And at least in principle, that should be more than enough energy to compensate for the energy needed to accelerate the protons. So you get rid of the waste and get energy out of it. Accelerating protons. Where have we heard this before? Yes, that's what they do at CERN, and indeed the idea came from Carlo Rubbia, a particle physicist at CERN who came up with it 30 years ago. He called it an energy amplifier because that's what it is. You put in the neutrons and that encourages the waste to release more energy. If this method was used on the existing radioactive waste, then the remainder would take only about 500 years for the radiotoxicity to decay to that of natural uranium. Why don't we have this technology already? The major problem isn't the neutrons. Particle physicists know how to create neutrons. The problem is that you have to be very careful with what you put into the fuel, because if you mix in some of the wrong isotopes, you might accidentally create more nuclear waste that's very long-lived. So you need methods to very cleanly separate radioactive waste into different isotopes, which, well, not many people have had to do, and so the technology doesn't really exist. One of the companies that says they can do it is Transmutex. Their design for an accelerator-based reactor was just approved in Switzerland. So if all goes well, we can just hand over our nuclear waste to the Swiss, and they can make energy with it and replace a few more particle physicists with AI. Another thing you can do to shorten the lifetime of radioactive waste is to shoot at it with lasers. This too isn't a new idea. It's been around for 2 decades at least. It received some headlines after Gerard Mourou won the Nobel Prize in 2018 and said, hey, here's this other thing you can do with lasers. Though he made more headlines by pretending to sing with his students. Lasers are notoriously energy inefficient, So economically, this is not a particularly great idea, but it can deal with some of the remaining long-lived nucleotides that the neutron firing can't do anything about. Notably, lasers have been used to successfully transmute iodine-129, which has a half-life of 15.7 million years, into iodine-128 with a half-life of a mere 25 minutes. So in summary, what do we do with the radioactive waste? We recycle the part that can be recycled, shoot neutrons at what's left, give the remainder a laser treatment, and then we sell the rest to aliens. More work is needed on the last point. I'll keep you posted, so don't forget to subscribe. If we ever want to be able to live on other planets, we need to find a way to make them more Earth-like, a process that's been dubbed terraforming. The ideal test project is Mars. Today I want to tell you about a new idea for how to terraform Mars, which is crazy of course, but if we don't think about it, we'll never make it happen. So let's have a look. Mars isn't all that different from Earth. It's our next neighbor planet, about 100 million kilometers further away from the Sun than we are. With current propulsion systems, it'd take about 7 months to get there. Mars is noticeably smaller than Earth, with about 1/10 of the mass and 1/3 of the gravitational pull. It has an atmosphere, but it's very thin and unbreathable for us. It contains basically no oxygen and is mostly carbon dioxide and nitrogen. We could live in habitats with breathable air, but there is another big issue with Mars. The larger distance from the Sun and lack of a warming atmosphere makes it very cold. The average temperature is just about -60 degrees Celsius or -80 Fahrenheit. But there is good news too. We know that there is water on Mars. There's ice on the poles and more ice underground. So we have water, soil, sunshine and carbon dioxide, which is not such a bad combination if it wasn't just too cold. This is why most of the plans for terraforming Mars begin with trying to warm it up so that the water melts. This could make the soil fertile and allow plants to grow. One way to warm Mars would be to add more carbon dioxide to the atmosphere. And there is some carbon dioxide left on Mars, but it's also frozen at the poles and in the ground, and it isn't enough. This remaining carbon dioxide alone would only raise the temperature by 10 degrees at most. Some researchers have suggested using artificial greenhouse gases like chlorofluorocarbons to warm Mars. But the chemical elements to produce them, notably fluoride, are rare on Mars. The authors of the new paper now have a pretty ingenious idea. It's to use the dust, which is everywhere on Mars. Mars dust is already in the atmosphere. You can see this in some of the photos. Normally, it has a somewhat cooling effect on the surface because it reflects light. But the authors of the paper point out that this isn't because of the constituents of the dust. It's because of the typical size of the grains. They're fairly large. If you grind the dust to nanometer-sized particles, it'll become very good at absorbing radiation in the infrared. So it'd warm the planet. And it would warm it substantially, enough to melt the ice. You see this here in this figure, which shows the temperature dependence on the density of the nanoparticles. For reference, the freezing point of water is at about 273 Kelvin, and the average temperature on Earth is roughly 288 Kelvin. This figure shows the result of a climate model calculation for Mars. The blue line in the middle is the average temperature, and the shaded region is the seasonal variation. Since the temperatures are higher near the equator, some of the ice starts melting in the Mars summer past the white triangle. Better still, they say that within a couple of months, the temperatures would be high enough for the frozen carbon dioxide to melt, which would increase the atmospheric pressure to about 1/5 that of Earth and add some further warming. One thing they didn't discuss in the paper, though, is that there's a reason Mars doesn't have an atmosphere. It's that it doesn't have a magnetic field, and that allowed solar wind to rip the atmosphere away. So if you want to get any atmosphere on Mars to last, you'll have to think of a way to fix that problem. A few years ago, two physicists suggested that this problem could be fixed with a big superconducting wire around Mars. So that'd have to be about 3,400 kilometers long. Clearly, we won't be doing any of this in the near future, but I like looking at mega projects like this, or the idea to build a giant chimney to cool Earth or an elevator into space. It's because the challenge in getting these things done isn't technological, it's economical. We don't have the capacity to pull it off, not yet. But if we play it smartly, we'll get there. And who wouldn't want to have a second planet to screw up? A new theory of consciousness just dropped, and it's quite an ambitious one. Not only does it supposedly explain what consciousness is, it also gives you free will, and all of that thanks to quantum physics. It sounds like bullshit, but it comes from Hartmut Neven at Google Quantum AI, and my favorite panpsychist Christoph Koch. Though saying that I have a favorite panpsychist is kind of like saying I have a favorite type of moldy bread. I had a look. Hartmut Neven is a German computer scientist and currently vice president of engineering at Google, so not exactly a crank. He's the Neven of Neven's law. That's the insight that exponential scaling of an exponential scaling makes a double exponential scaling. Amazing stuff. Christoph Koch is one of the biggest proponents of integrated information theory, IIT for short. According to this theory, consciousness can be measured in a single number, the big psi, which can be calculated from the connectivity of a system. I wouldn't exactly call him a crank either. Oh, and these two have 8 co-authors who'd be insulted if I didn't mention them, so just imagine I read the entire list and you forgot about it. For what I'm concerned, IIT was killed years ago by Scott Aronson, who showed that there are ways to distribute the execution of simple algorithms on computer chips so that it'd have arbitrarily high consciousness. Then again, maybe my psi just isn't high enough to understand what these geniuses are even talking about. The new paper now is supposedly an improvement over Penrose's idea that the collapse of the wave function causes consciousness and that this happens in the human brain every once in a while. You see, in quantum mechanics, particles can do this weird thing that they come into what we call a superposition, in which they do different things at the same time. Say they go both left and right. But we never observe this. When we observe a particle, it always does only one thing. It's either left or right. This is why we say that the state of the particle, which is described by a wave function, collapses when we look at it. It collapses into a normal, definite, non-quantum state. The trouble is, you can't observe the collapse itself, because whenever you observe a particle, it's already collapsed. It's kind of like my invisible friend who leaves the room each time you come in. The reason that Penrose thinks the collapse of the wave function creates consciousness is that he believes consciousness can't be computed. And since we know that everything besides the collapse of the wave function is computable in physics, the collapse must be it. Penrose also has this idea that the collapse of the wave function is caused by gravity, though that process is calculable, so make of this what you wish. The authors of the new paper now say, first of all, let's forget about gravity. Second, they discard the idea that consciousness is caused by collapse. Instead, they postulate that consciousness is created when a superposition forms. What happens with the superposition later? Nothing, because these people believe in the many worlds interpretation. Basically, their idea is that in the brain, you could get superpositions of possible experiences. Say, instead of a particle going left and right, your brain might try to produce an experience in which this sentence is both funny and not funny. But you never experience this. What you experience is a sentence that's either funny or not funny. So in the moment when the funny, not funny superposition could be created, your brain needs to select one. And in that moment, so their idea, consciousness is created. That might sound plausible if you phrase it in words, but mathematically I see a few problems. The biggest problem is that their idea of experience is ill-defined. The maths doesn't know that funny and not funny is not something you'll ever experience. Mathematically, funny and not funny is exactly as good or bad as funny, or not funny, or funny minus I times not funny, and so on, even if that doesn't sound funny at all. They try to define experiences as those states of your brain which will eventually not decohere, and say that you could use IIT to define it, but if they'd actually written down a definition and tried to calculate something with it, they'd have noticed that it doesn't work. How do I know that? Because no one's ever managed to do it. There's just a lot of physicists who think someone else has done it. It's actually quite funny. Or maybe both funny and not funny. In any case, since they don't have a definition for what an experience is, they can't explain anything, I'm afraid. But wait, there's more. Next, they say that they want to test this idea by connecting a brain to a quantum computer because this should enable richer conscious experiences and make you a quantum cyborg. Yes, I'm pretty sure that hooking your brain up to a quantum computer will be quite some experience. They then argue that this sort of expanded consciousness occurs during psychedelic, mystical, near-death and other types of extraordinary experiences. I'm sure lots of students will be sympathetic to the idea that quantum mechanics is a sort of near-death experience, but I'm not sure that this explains anything. Finally, they claim that this gives humans free will because maybe an organism can exercise some degree of choice in the libertarian sense over which classical configuration it is going to experience next. And what, I wonder, is it going to exercise that choice with? Is it free will that creates free will? This might leave you thinking this paper's pretty useless, but it does have a very interesting aspect. It's that the authors don't notice that their theory is super deterministic. You see, they split the experiences at the moment the superposition is formed. This is not the case in the many worlds theory. In that theory, the worlds only split when the measurement happens. If you instead split worlds when the superpositions form, you have for practical purposes invented a local collapse model. And now Bell's theorem comes to bite you, because that tells you that such a theory needs to be superdeterministic. That is, it has a hidden variable that's correlated with the measurement that you make. What's the hidden variable? Well, that's the experience which forms instead of the superposition. Why is it correlated with the measurement setting? Because once you've selected this one thing as an experience, you know that you'll not measure a superposition of it with something else. In summary, I think the idea is both interesting and not interesting. I quite like eating insects. I'm vegetarian, not for dogmatic reasons, but just because I don't like meat. But I do like these crickets and maggots and also the grasshoppers. Though I usually take off the wings because they keep getting stuck between my teeth. I wouldn't mind if in the future we'd farm crickets instead of cows. And this isn't the only idea for future food that scientists have come up with. There's also 3D printed meat, mushrooms, algae and jellyfish, among other things. Let's have a look. Meat alternatives have made a lot of headlines in recent years. There are several reasons for this. One is that growing animals is much more energy intensive than growing plants. A lot of energy and carbon emissions could be saved if we stopped eating meat. According to a study from the University of Oxford, shifting to a vegan diet could cut food-related greenhouse gas emissions by up to 70% globally. That'd be about 16% of the total, a really big chunk. We could even cut them by 100%. We just all need to stop eating. But it's not just about climate change, it's also about land use and independence. Many countries are looking into new food production methods, so they have to rely less on imports or because they're running out of space, especially in densely packed areas like Singapore. Insects are an obvious replacement for meat as a source of protein and fat. The idea isn't new, of course. People have eaten insects for thousands of years, or millions, depending on your definition of people. It's remained somewhat of a niche food because, for one thing, it's hard to come by with decent amounts, but also because wild insects might carry diseases and parasites, and I don't know if you've ever tried to wash a grasshopper, but it's not all that easy. That's why companies have looked into making insect farming cleaner and more efficient. They often don't just sell the entire insects, they make other food products from them, such as protein bars, oils, or crisps. They sometimes also offer pet food. That said, I have noticed that insects aren't for everyone, so let's have a look at something closer to what you know and like: lab-grown meat. The idea of growing a nice succulent chicken thigh in the laboratory has been around since at least the 1930s. In 1931, Winston Churchill even predicted that 50 years hence we shall escape the absurdity of growing a whole chicken to eat the breast or wing by growing these parts separately under a suitable medium. Synthetic meat is usually produced by first taking some muscle tissue from a living animal. The muscle cells are then supplied with nutrients and grown into larger structures like muscle fibers and eventually chunks of meat. This process has been refined over the decades, but texture has remained somewhat of a problem. The Spanish company Coquios wants to fix that with 3D printing, which also helps create some relatively normal-looking meats. This isn't the only problem with synthetic meat, though. Another issue is to get the muscle fibers to integrate fat. This problem could be partly solved with yet another food alternative: mushrooms. Mushrooms, or to use the more general scientific term fungi, have been around as meat replacement since the 1980s. The first was the British brand Quorn, which is still around today. To produce it, one grows a tiny fungus under controlled conditions. The product has a high content of protein and fiber and a structure that resembles chicken breast if you don't think about it too much. Today, companies are still producing similar products, which are named mycoproteins. Mycorrhiza is one such company. They have produced protein alternatives, but they've also developed a fat-like product that can be used to make synthetic meat juicier and tastier. Most dedicated meat eaters probably won't be convinced by this stuff, at least until now. But in the end, meat is just a particular arrangement of molecules, and sooner or later, I'm sure, we'll find a way to produce it without actually growing and slaughtering an animal. An entirely different avenue is to just go for plants and make sure they grow quickly and efficiently. Algae farming, which includes a large variety of species, is the best example for this approach. To be fair, they mostly look like slime, but many algae are high in fiber, proteins, carbohydrates, fats and vitamins, making them a very useful food source. Better still, they're very resilient and grow fast. I like seaweed salad and also dried algae and wouldn't mind seeing a larger variety of the stuff in the supermarket. I swear this video is not sponsored by the algae industry. But algae haven't been bred as much as other plants, and scientists are still using genetic engineering to make the farming more efficient. Besides just eating the stuff fresh or dried, one can also process it to powder that can be added to soups or stews. Lastly, let's take a look at one of the more out there prospects for our future diets: jellyfish.
Jellyfishing, 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 jellyfishing.
They're not just a nuisance for fishermen or pretty decoration for fish tanks. Jellyfish are also considered a delicacy in China for their unique texture. In addition to having a nice crunchy bite, some species of jellyfish are also a low-calorie source of protein and vitamins. What makes jellyfish so interesting as a meat replacement, however, is that they grow very quickly and can do so in small spaces, so they're ideal candidates for indoor farming. Once harvested, you can eat jellyfish or turn them into other edibles or use them to feed other animals. The biggest problem with all these food alternatives is at the moment that they're all too expensive to make much commercial sense. But I'm convinced that 100 years or so from now, eating meat will be considered a rather uncivilized and mildly disgusting food choice. What will we eat instead? Well, in the end, there's always Soylent Green. Thanks for watching. See you tomorrow.